All right, here we go with homework 4-7. You have a Venn diagram here. Some people playing tennis and soccer, and little Jessica out here doesn't play either. Okay, but then you have these people in here who play both. So the question is, find the probabilities. Let's see, event A. Let A denote the students in the tennis club. B are the students in the soccer club. Okay, so this is just saying what's the probability that somebody is in the tennis club. Okay, we have 14 students total, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them playing tennis. So you got a 9 out of 14 chance of picking somebody in the tennis club. Part B of this, the probability of somebody being in the soccer club. 1, 2, 3, 4, 5, 6, 7. You have a 7 out of 14 chance of being in the soccer club. And then what's the probability of you being in the tennis and soccer club? 1, 2, 3 out of 14 chance. So we got a 3 out of 14 chance. Now the way you would read this question right here is, this question here is given, this says given B, what's the probability of A? So given you are in the soccer club, given this circle right here, we're only looking in that circle right there, what's the probability that you're in the tennis team? Okay, so given I'm only dealing with these 1, 2, 3, 4, 5, 6, 7 people, I have a 3 out of 7 of them are playing tennis. Okay, given that I'm in the soccer circle, what's the probability I'm also playing tennis? 3 out of 7. And then last, we would have probability of B, which is 7 out of 14 times 3 out of 7 would give us, if I simplify it, 3 out of 14, which is the same thing as this right here is what they want you to see, I think. So it says select the probability that A and B, it also equals this thing right here. So I would circle that right there. All right, get to play with that one a little bit. Next. Computing conditional probabilities. It says at a school's open house, t-shirts and sweatshirts were sold, each item purchased by either a student or a parent. And this is the frequency table. We sold 60 items. So if I add all those numbers up right here, it should get 60. All right. Oops. All right, so let sweatshirt be the event that an item randomly chosen from among those sold was a sweatshirt. Let parent be the event that was purchased by a parent. Okay, so the probability of a parent purchasing something. So out of the 60 purchases, this many were made by parents. So that is 27 and 9 is 36. So I got a 36 out of 90 chance, 36 out of 60 chance. I would type that in and write it as a decimal. The next one is, what's the probability of a sweatshirt and a parent? Okay, so here are the parents in blue, here are the sweatshirts in red. So where do they overlap? Boom, this 9 right here. So there's a 9 out of 60 chance of it being a parent and a sweatshirt being sold, or a sweatshirt sold to a parent. All right, and lastly, gonna erase some stuff here. The way you read this right here is given a parent bought it, given a parent, because you always start here, given a parent, what's the probability it was a sweatshirt? So what's the probability of the sweatshirt? All right, so I'm only looking, so given that it was a parent, I'm only looking at these 36. So there's going to be a 36 on the bottom. And then probability of a sweatshirt, well, there were 9 out of those 36 things sold that were sweatshirts. So I got a 9 out of 36 chance. Given that it was a parent, there's a 9 out of 36 chance that it was a sweatshirt. All right, moving on to the next one. All right, identifying independent events given their probabilities. So this is the main statement you need to know really for probability of events that are independent. If events are independent, then the probability of A and the probability of B equal the probability of A times B. But these other two rules also come into play sometimes. And this says given A and B are independent if given B, the probability of A is equal to the probability of A, and given B, and on the other side, given A, the probability of B is equal to the probability of B. These are a little bit harder to understand than this one right here. But this, as long as you know those three rules, these are easy to pick out, because this is saying, so this one right here, basically saying what I'm saying right here, okay? That the probability is 1/5. Yeah, so this is matching up with this right here. So it matches up, so those are definitely independent. Probability of A times the probability of B is equal to A times B. 1/5 times 1/2 is 1/10. This is basically saying this right here, so they're independent. A, B, but this is not equal to this, is not equal to this, so they're not independent. So we'll have to say they're dependent on each other. And this last one, given, trying to see, does it say this right here? No, because these values are different. So that would have to be dependent as well. So it's just basically write these three rules down when you're working this problem, okay? But really, the important one for independent is that one. In my opinion, this is the most important one right here. All right, moving on to the last one. It's another frequency table. And this time you have 166 doctors. So if I add up all these numbers right here, I should get 166. And I got to answer some questions, okay? So it says, what is the probability that a volunteer is a doctor given that the volunteer worked the morning shift? Okay, so here's what you got to learn to do. Given that the volunteer worked the morning shift, that tells you where to look. Given that the volunteer worked the morning shift, here's everybody that worked the morning shift. There are only 29 people that worked the morning shift, okay? Out of those 29 people, 19 of them are doctors. So the probability that a doctor worked the morning shift would be 19 out of 29. Next one, what is the probability that a volunteer is a nurse or work the afternoon shift? Okay, well, here are the nurses. Let me get rid of this a second. Okay, so here are the nurses. And there are, 43 and 27, 60, 70, 80 of those. There are 80 nurses there. And here are the people in the afternoon shift. Okay, there are actually 85 of those. But these people got counted twice. So out of the 166, how many have I circled here that are in green? It's these three right here plus this 42 right here. So these, if I take all these numbers right here and added them together, that's going to give me 122. 122 out of the 166 would be either a nurse or in the afternoon shift. All right, play around with those, and if you need some help, let me know.